Fusion headlines usually focus on the plasma, how hot it became, how long it lasted, or whether an experiment produced more fusion energy than the laser energy delivered to the target. A power plant has to survive everything around that plasma. In June of 2026, the United States Department of Energy released a finalized fusion science and technology roadmap aimed at closing the gaps between experiments and pilot plants. One of the hardest gaps is the blanket, the structure surrounding the fusion chamber. In a common deuterium-tritium design, fusion releases a fast neutron. The magnetic field cannot steer that neutron because it has no electric charge. It flies into the surrounding material, where its energy must be captured as heat. That heat eventually drives the equipment that produces electricity. But the neutron also damages material. It can displace atoms, create defects, change mechanical properties, and activate components. A material that looks strong in an ordinary laboratory may swell, become brittle, or lose useful life under a fusion neutron environment. The blanket may have another job: breeding tritium. Tritium is a scarce hydrogen isotope used as fusion fuel. Designs often place lithium-containing material around the chamber so neutrons can help produce new tritium. The plant must extract it, measure it, limit losses, and return fuel to the plasma. A workable system needs to breed enough to replace what the reactor consumes, while keeping the total inventory controlled. Now add cooling. The blanket has to remove enormous heat, resist corrosion, contain flowing materials, preserve structural strength, and allow maintenance in a region that may be activated. The Department of Energy roadmap calls for test loops, material data, tritium extraction, remote handling, and eventually integrated blanket demonstrations. This is why a new plasma record can be scientifically important, without meaning a commercial plant is one construction project away. The plasma proves fusion conditions. The blanket, fuel cycle, materials, maintenance system, and power conversion have to turn those conditions into reliable electricity. The milestone to watch is not only whether a machine creates fusion. It is whether the surrounding systems can repeatedly capture the energy, sustain the fuel, and be repaired on a schedule a power business can afford.